Chapter 6 is up next for reviewing for our final. Now, before I started my video, I went back to my, let's see, where did I find this? I think I found this on my 6-3 homework. This is that list that I had you made on the back of your 6-1 notes. I'm trying to make it bigger for you. I stole this from a student, so student who you know who you are. Thank you. I'm gonna crop it just so I have just what I need. You are obviously, I can't stop anybody from using their notes and their stuff, so we are encouraging the use of your tools and everything that you have learned. So even if you haven't, maybe like scroll back and take a screenshot of this one and use this one for your final, but have this available for you when you do your final, so you have your lists of your squares, cubes, fourths, and fifths. If you don't, like, okay, that's like totally your choice. I would definitely make sure that if I were you, I would have it there. Let's go ahead and take a look at the review from chapter 6. So it says find all the real square roots of positive 0.0004. So the first thing I want to make sure is that it says real solutions. So they are not looking for the imaginary solutions. And square roots means we look at our square list. So I know that the square root of 4 is 2. Okay, there are 1, 2, 3, 4 decimal spots in the original divided by a square. A square is like 2, right? So there's going to be 2 decimal spots at the end, so 0.2. So it does say find all of the square roots. That word is all, and square roots is even. So that's a positive and a negative 0.02. So in other words, both of those things squared would give you that answer. Now I wanted to compare that. I have a versus here. Find all the real square roots of this fraction. So again, we're not looking for imaginary when it asks us for the real solutions or the real roots. So in other words, they're asking me like, okay, what is the square root? What is the positive and the negative square root of negative 9 over 16? The real answers. Well, square roots can't be negative. So I'm actually going to write no real roots. Now, if you're like, I thought there, like, we could do like a 3 over a 4 with an I, because the square root of 9 is 3 and the square root of 16 is 4, and that would be a positive and negative I. Yeah, that is true, but they weren't asking for the imaginary solutions, so I'm not going to list the imaginary solutions. P.S., maybe we should just like definitely make sure I indicate if the word is square, that's even. If the word is fourth, that's even. Those cannot be negative. Now, if that's a cube root, maybe I should even throw that in there. If it was the cube root of like negative 27, that's okay. The answer would be negative 3 because the cube root of 27 is 3 and cube roots are allowed to be negative inside. Take a look at number 2, simplify the cube root of those items. So let's look at my list. We're going to hope that we see 128 on our list, although I know we're not going to see 128 when we go over here to our cubes. So I'm going to try to divide by anything underneath of 125 because I know 125 isn't going to go in there. So I'm going to divide by 64. So if you want to get your calculator, feel free to do that. When you do, like you're going to do 128 divided by 64. If you get a decimal, move to 27. If you get a decimal, move to 8. So 128 divided by 64 is 2, and it's a clean cut 2, which means 64 is the number you want to be using. So make sure you look at your right list. So I'll do 64 times 2 for my 128. Then what I do is I apply the cube root to both of those, and the cube root of 64 is not 8. Everybody thinks it's 8, but that's the square root of 64. The cube root of 64 is 4, and you can use that chart to indicate that. See 64 and 4. And then the cube root of 2 stays put. There is no cube root of 2 or anything that goes into it. Now I want you to think about your the A's. You're pulling them out in groups of 3, so I can draw all 13 of them if that will be helpful. Fast forward the video if you know what you're doing. 1, 2, 3. Okay, just going to double check them. Okay, so I have 13 of them, right? I can pull out groups of 3. Okay, so I got 1, 2, 3, 4 groups that I can pull out. So I can do a to the 4th because I have that 4 represents 4 groups of 3, but I still have 1 left over. So here's my 1 left over. You don't need to write the 1 on that. And I'm going to do the same thing with my B's. 1, 2, 3, 4, 5, 6 groups of 3. none left over. So that would be two groups that I'm able to pull out, none left over. So this is our final, sorry, that's a really bad color to highlight on top of that. This is our final answer. Okay, number 3, rationalize the denominator. The word rationalize means no square root or I in the denominator. Rationalize means get rid of the square root and the I in the denominator. So the only way to do that is to look at the denominator. The numerator does not affect you on what you pick in the first step. So we have to multiply by the conjugate of the denominator. So the conjugate of the denominator is the square root of 7 plus the square root of 8. What you do on the, oh, not square root of 8, excuse me, just 8. What you do on the bottom is exactly what you need to do on the top. That is the only way that you're going to be able to rationalize this problem. I will do the bottom first, and then I will do the top. I always suggest doing one and then the other, not doing like go back and forth, back and forth, back and forth. So I will throw parentheses on there so I can see that it's going to be this type of problem. And I got 4 things. Square root of 7 times square root of 7 is square root of 49, which PS is just 7. The square root of 7 times the positive root of positive 8 is 8 square roots of 7. Negative 8 times the square root of 7 is negative 8 square root of 7. Remember, those don't make 56 because the 8's on the outside. Negative 8 times positive 8 is negative 64. If we've done our jobs right, these middle terms will always cancel, and we'll be left with 2 whole numbers down there. So that's 7 minus 64. 7 minus 64 is negative 57. I will put that negative in the top eventually, but I have worked the denominator out, so there's no more square roots down there. That's what a conjugate will do. Now for the top, I'll just do the top in a different color to differentiate. All right. PS, the one in the final might not have like the square root of 3. You might just distribute a 5. Okay. So just be careful that you only distribute what they give you. So 1, 2, 3, 4. 5 times the square root of 7 is just 5 square root of 7. 5 times 8 is positive 40. Square root of 3 times square root of 7, well, it's a negative square root of 3, is negative square root of 21. Negative square root of 3 times positive 8 is a negative 8 square root of 3. Because the 8's on the outside, the 3's on the inside, and the whole term will be negative. Let's check and see if we can reduce. Does anything go into 7 from my square list? The answer is no. Does anything go into my 3 from my square list? And remember, we don't worry about 1. The answer is no. Does anything go into 21, like 9? No. So those all stay separated. We can't put anything together because nothing matches. So since none of the square roots match, that answer is the really ugly numerator. So what I'm going to do is I'm going to write my final answer after this equal sign. I'm going to put the negative from the 57 out in the front. So I'm going to put my 57 here. I'm going to put my negative in front. That came from the 57. And then I'm going to write the entire numerator up here. That's an ugly answer. I like it when you can put them together, but that's what happens when you make things up. Now, you might see this negative being distributed, and that would be okay. It won't be in front anymore. I'm not going to. All right, but you won't see an answer where it's a negative on the bottom. Okay, number 4. So number 4 is actually a lot more simple than number 3, because number 4 we're just multiplying like 1, 2, 3, 4. There's no rationalizing, we're just multiplying. So 8 times 9 is 72. 8 times the square root of 5 is 8 square root of 5. Negative square root of 2 times 9 is negative 9 square root of 2. And negative square root of 2 times 5 is negative square root of 10. Okay. Now let's see if anything matches or anything reduces. So I'm going to check reducing first. Does anything go into 5 from my square list? No. Does anything go into 2? No. Does anything go into 10? No. Do these match? No. Then I'm done. That's also another ugly answer. I mean, if they match, you have to like put them together and stuff. Number 5. What is this exponential expression written in radical form? So exponential expression means it has an exponent. Radical means it has a radical. Maybe the index might, but it depends. So I thought it would be nice to give you a versus, like one versus the other with parentheses versus without parentheses. So let's say you do have parentheses. That means that, okay, this is the root to the bottom. So it's like the root of the tree. It's the root. This is the exponent. Anything in parentheses goes inside your square root. So 4 and x get an exponent of 2. Ooh, this is actually kind of an impressive little problem here. So I need to apply that squared. So I get the cube root of 16x squared. Oh my. Okay, I didn't realize that this would keep going because there is a cube inside of 16. I know my cube, so I know that 8 is in 16. So I'm going to have to go, where's my problem? I'm going to have to divvy this up to be 8 times 2. I don't have enough x's to pull any out. So the cube root of 8 and the cube root of 2. Watch how that works. Final answer, the cube root of 8 is a 2 on the outside. The cube root of 2 is trapped. And then I do not have enough x's to bring out any because I would need to put them in groups of 3. So I'm just going to like, there you go, put that next to that a little bit more. Okay? Looks good to me. Now I want to show you the difference between that one and one that doesn't have parentheses. So this 4 is not affected by the 2/3. The 4 is not in the cube root and it does not get an exponent. So that one is all done and we don't have enough to pull any out. See, I have a class starting in 4 minutes. Let's see if I can make it. Number 6. Yeah, I'm not going to make it. Number 6, I need to solve the equation. So solving the equation means solve for x. So I got to get x by itself. So first I'm going to have to add my 7 to the other side. So it's going to be the square root of x plus 10 equals 2. And now my x is trapped by a square root. So to undo a square root, you do the inverse, which is squaring. So that's going to get rid of my square root because the square root squared is canceled. And 2 times 2 is 4. Take away 10. X is negative 6. You should check this solution because it might not work. So we would do the square root of negative 6 plus 10 and then a minus 7 and hope to get negative 5. And sure enough, this would be the square root of 4 minus 7, which is 2 minus 7, which does check out. Okay, so there's the check. My watch is going off. It's like, go to your class. I got 2 minutes. I got 2 minutes, watch. Here we go. Number 7. I'll at least finish number 7 before I start my video again. It asked me to solve and check for extraneous roots. So I got to get x by itself, which is actually maybe a little more difficult than what you might think, but not overwhelming. It's just the fact that x is trapped inside that square root. And when x is trapped in a square root, we're going to have to square both sides. So this is ready. The square root is by itself over here. Like there's no like plus 7 or anything. So it's ready to go ahead. It's ready for me to square it. So I'm going to square this side. Whoa. I did not mean for that to be that large. And I'm also going to square the other side. So when you square the left-hand side, sometimes we forget about that poor little 6, or sometimes people act like there's a plus sign between the 6 and the x. It's just 36 x squared, and the square root drops off here. A squared and a square root cancel each other. All right. Now, excuse me, please. I notice I have an x squared, and by this time, I'm guessing in Algebra 2, most of you know, when you have an x squared, there's a pretty good probability that you're going to need to set this equal to 0 and do the quadratic formula, which in this case I will. Excuse me, I'm sorry. So I'm going to take away 24. I'm going to take away 12x. I'm going to set it equal to 0 because if I set it equal to 0, I can do the quadratic formula, possibly even factor it. So that is 36x squared minus 12x minus 24 equals 0. That's my bell to start my class. I'm going to finish this problem with you though. Now, you guys go ahead. If you want to, if any of you see it, you're more than welcome to divide everything by 12. If you don't see that, like That's okay. The quadratic formula is incredibly forgiving. So we are going to, I'm just going to do the quadratic formula because I'm going to guess about 70% of students are not going to see that you can divide everything by 12 to make it easier. So if that's the case, I'm just going to do positive, or excuse me, negative b, which is positive 12, square root of b squared minus 4ac. And you might say, wow, you're doing that really fast. And quite like at this point in time, you guys should be able to do your quadratic formula this fast. If you can't, that's good. Just pause the video and catch up, okay? Going to grab my calculator. Let's, oh, look at those cute kids. All right. And as silly as this might be, I am going to start my class online as well, simultaneous. This will be fun. Okay. All right. And now it's time for me to type this stuff in from my quadratic formula. Let's see. So I'm going to do negative 12 squared minus 4 times 36 times negative 24. Make sure you use parentheses around your negatives. So that is 12 plus or minus the square root of 3,600. That is a perfect square, which is really nice. So it's 12 plus or minus 60 over 72. And, oh, it's quiz day. Nobody's coming to the Zoom. See, it's a good thing I didn't stop my recording. So 12 plus 60 is 72 over 72, which is 1. 12 minus 60 is negative 48 over 72. Which is negative 2/3. All right, so if that's the case, I'm going to guess only one of those actually works. And I can look at that right now and tell you negative 2/3 won't work because 6 times negative 2/3 is a negative number. And when you take the square root of 24 plus 12 times negative 2/3, I can promise you you're not going to get a negative 4. Okay, so that one's out. What about, okay, so we know 6 times 1 is 6. What about the square root of 24 plus 12 times 1? Just checking my answers. There we go. So we got 6 and 6 on both sides. So sure enough, 1 is the only solution. Nobody's joining me on my Zoom. Makes me feel sad. Okay, number 8. Let's say that we are given this equation and it says find f of x plus g of x. So we are given, we can color code it if that will help. We're giving f of x to be this and g of x is this. So they want us to take, which one first? They want us to take f of x, which is negative 3x minus 6. They want us to add g of x, which is 5x plus 2. So essentially, I'll distribute my positive. So I get negative, I'll change to black so you know it's like molded. I'll change it to brown because orange and red, actually orange and red doesn't make brown, but that's okay. So that would be negative 3x minus 6 plus 5x plus 2. Distribute your positive. Final answer, 2x minus 4. I'll even highlight that in poopy brown just for you. So the final answer is 2x minus 4. So they just wanted to add the two equations together. That's kind of like the long story short. Okay, given the following equation, I'll keep my calculator there. Find f of g of negative 1. Now, if you can't remember, this is called composition. Does everybody see that open circle? That is not multiply. That is called composition. Okay, so composition wants me to do this. It says take negative 1 into the g equation. So it's going to be, I'll draw an arrow. It's going to be 4 times negative 1 plus 6. It's a final answer of 2. Then this final answer of 2, they want you to put that into, which one's after that? Then you go to f. Here's my arrow. F is a negative 2x squared, so 2 squared minus 3. So just to kind of emphasize, this 2 is right here. So let's see, it's going to be 4 times negative 2 is negative 8. Negative 8 minus 3 is negative 11 for a final answer on this problem. That is definitely going to be on your final. I just think it's a very important concept, composition. Number 10, find the inverse of the equation. So inverse means you switch x and y. It's 2 steps. Switch x and y. And number 2, solve for y. There. So those are your 2 steps. Switch x, so inverse. That's the definition of inverse. Okay, so we're going to switch x and y and solve for y. I'm going to move over because I am running out of room. Wow. What's that going to be? X plus 3 equals 7y squared. Divide by 7. Move over because, again, I'm running out of room. So it's x plus 3 over 7. Take the square root. When you physically draw a square root sign, remember to use plus and minus. Sorry, I know I wish I could work down, but I'm working over. So we'll have a positive and a negative. Square root of x plus 3 over 7. That equals y. This is your inverse equation. And if you're wondering, like, what in the world did you just write? That f negative 1, that means inverse. Just like by definition, when you ever see an f to the negative 1 power, that means inverse. That's why I wrote it. You'll see that on your SATs. Okay, number 11 is the last one. Choose the correct graph. Well, probably the easiest way to do this is to go to y equals, maybe even Desmos, and type in square root x plus 3. Hit graph. It's going to be that one. Now, in my, in a perfect world, all of you know that a square root graph looks like this. Okay. And also on top of that, all of you, I'm hoping, remember that when you have a plus 3 on the inside, that means left. So you're going to take that shape and you're going to move it to the left 3 units. That's why the answer is C. You can see how it like goes left 3 units. It doesn't start at 0, 0. It goes left 3 units and then it has that shape to it. All right, that in a nutshell is chapter 6. I mean, like, you could expect if there's a graph one on the final, I mean, you could expect maybe the 3's on the outside. So, you would want to pick the graph that looks like it got moved up 3. Composition, I mean, composition's pretty much like number 9, what you're going to see. Inverse, switch x and y, solve for y. So when I do these notes here on this review, like these are all things that you should write down for yourself. Or if there's things like, you're thinking like, oh, I'm going to need to remember that particular rule on the final. Maybe, I don't know, can you add a note or something or add a sticker? I'm not sure. Maybe like a little blank note and you can say like, okay, here's like on this one, here's what I messed up. Like this is what I need to look out for. So take really good notes for yourself so that you know when you come to the final that you have these notes that you can reference for yourself. All right, guys, thank you for your time. Thank you for your attention. Have a great day.